Welcome back. We're going to start now our two-sample testing. So before we had a single sample, and with that single sample we would see if we believe the null hypothesis, or what was believed to be true in the past, is true or not true, or reject or not reject. So this follows the same process as before. The only difference is we're pitting one population versus another. So getting a sample from one population, getting a sample from the other, and then we're going to do a test on that. So see if they are different from one another, all right? So, if you subtract the age of two people, if we want to see the difference of their ages. So Joan, she's 20, and Nick is 20. So what's the difference in Nick and Joan's age? Well, 20 minus 20 is 0. So no difference is the number 0. So keep that in mind. No difference is 0. So we're going to see that up here in just a second. So let's take a look at this first problem from the handout that I made, and we're going to walk through it, and hopefully you get a good understanding. A researcher wishes to see if there is a difference in the manual dexterity of athletes and that of band members. Two random samples of 30 is a good number, are selected from each group and are given a manual dexterity test. The mean of the athletes' test was 87. So I set up one group. Athletes will be population 1. Band members will be population 2. So I call it X bar 1, that's 87. And the mean of the band members was 92. So X bar 2 is 92. We already found earlier in the problem that the samples are size 30. So N1 is 30 and N2 is 30. Lastly, it says the population standard deviation for the test, for the whole test, doesn't matter who it is, if it's a band member, or if it's an athlete, or if it's just a scholar, it's standard deviation of 7.2. So we're going to use that for both, 7.2. So let's mark that down. That's going to be sigma 1 and sigma 2, 7.2 and 7.2. They didn't give us two individual ones. This is not always the case that it comes out this way. But for this one, we're going to use the same standard deviation for both. So the question is, it says at alpha equals 0.01, so that's our size of rejection region, 1% of the graph. Is there a significant difference in the mean score? So remember, if something's different, the difference is not 0. So let's set up our step 1. Now when you do these, especially when it comes to your final exam, I want you to number the steps. Shouldn't be too tough because you can refer back to notes, all right? You don't have to memorize. So step 1, mu1, that's the mean dexterity of athletes, and mu2, also Pokemon, is the mean dexterity of band members. So what I'm going to do is subtract the two. So the first one is our null hypothesis. There's no difference because the question is always the alternate. The question was, is there a difference? Which means the difference is not 0. Think about that. If I subtract the 2 and it's not 0, they're different. Okay? So my null hypothesis is mu1 minus mu2 equals 0. Okay? That means there's no difference between the two numbers. My alternate hypothesis, this is what we're trying to see if it's true or not, is mu1 minus mu2 is not equal to 0. That means there's a difference. All right? Keep that in mind. That means there's not a difference. Our assumptions are the same as before. The only difference is we're going to double it up. All right? So X bar 1 and X bar 2 are from a simple random sample. N1 and N2 are large. And sigma 1 and sigma 2 are known. Remember, that's the reason why you do a z-test when you know sigma. When we don't know sigma, we do a t-test. Repeat that back to me. When we know sigma, do a z-test. When we don't know sigma, do a t-test. Did you repeat that back? I hope so. So I looked on my chart. Remember our chart that I gave you a while ago of critical values. So along the top it says confidence intervals, and it has one tail, two tail. This is a two tail. Remember the not equal sign is two tailed. So we look up two-tailed 0.01. And I go clear to the bottom for a z-test, and it says 2.576. But we need it on the left, and we need it on the right. So it's positive and negative, 2.576. So that means our sketch looks like this, all right? So my parameter in the middle, remember parameter comes from a population, that's mu1 minus mu2. We're measuring the difference, all right? And if we're far enough away with our test statistics, step 4, if we're far enough away, we're going to reject. If we land in the middle, we're not going to reject. All right, so let me erase some things here and let's do some calculation. I wrote the formula at the very top here. Don't be worried about the formula. We know all the values. The only one I want to show you that's weird, okay, is mu1 minus mu2. But if you remember from our null hypothesis, didn't we say mu1 minus mu2 was 0? So we're going to put a 0 in that spot. All right, so substituting our values in from this problem, z equals x bar 1, which is 87 minus 92. All right, so we just filled in for the x bars. We did that. Minus, remember that difference was 0, stated in our null hypothesis. Divided by the square root of, remember our sigma is the same this time, so 7.2 squared over 30 plus 7.2 squared, that's S2, or sorry, sigma 2, over 30, and that's N2. So they're all matching this time. Rarely happens. And when I do that calculation, I get a negative value, 2.690. That's my Z test statistic. So where does that land? Let's see, if 0 is always the center in a standard normal distribution, here's negative 2.576. Oh, we're a little bit farther. We're farther left of that. So Z must be right there. We ended up in one of our alphas. Remember, alpha was split, half of it on one side, half on the other. We're going to reject, all right? We have enough evidence from this sample that it's far enough away. There is a difference. So I'm going to write that right up here, and I always do my conclusion the same way. So here we go. Number 5 is my conclusion. Reject HO, which means null hypothesis. There is significant evidence to suggest. What am I suggesting? There is a difference, right? A difference. I'm suggesting a difference in mean dexterity. Between who? Between athletes and band members. Okay, let's talk a little bit about this. All right, so the conclusion always has to match the alternate hypothesis, and the alternate hypothesis had a not equal sign in it, okay? And that means different, all right? It didn't say greater, it didn't say less. It just said not equal, which means different in statistics, all right? So we had significant, we rejected, we have significant evidence based on our numbers. And what's it suggesting? A difference. I didn't say it's greater, I didn't say it's less, I just said it's different. And the mean dexterity between the athletes and the band members. Make sure you use context in your problem. This problem had to do with athletes and band members. So don't just say there's a difference and end it. Write some words about it, okay? Use your verbal skills when doing this. Okay? Hopefully that makes sense to us. It's a little bit of review of old things that we did. We just added a second set of values. So our next video will be the second problem, and we'll do the 2-sample t-test for mu.